Alright, 5.3 Polynomial Functions. This section here is centered around two topics. First one is evaluating a function at a higher level, which of course means 6-weight, and using analysis to describe the behavior of functions and graphs. The first part is closer to our past experience, so we'll start there. So looking at this, some examples that you're going to see. Again, I can't really teach you this because you're supposed to already kind of know it, to where if you have f of x equals 3x minus 2, and you want to find f of 2, that you should know how to do this, but the other ones are a little different. But again, we're starting where we're familiar, that we know that what we do is we take our 3, we change our x into a 2, we rewrite everything else, and we work it out. 6 minus 2, which is 4. So this is considered our warm-up problem. Now, what is f of x plus 6? What that means is take x plus 6. Just like here, we put this in for x. It means put that in for x. So you take this and put it right there. So 3 times x plus 6 minus 2, which then becomes, as you distribute, 3x plus 18 minus 2, which when you put your like terms together, 3x plus 16 would be the answer to that. And then what is f of negative x? This is where you have to be careful because it seems easy, but again, if you put a negative x in there, it does kind of mess some things up. That means you end up with negative 3x minus 2 as your answer there. But again, that is a question that just wants to make sure you are disciplined enough to do what you need to do. Also, it's a warm-up for where we're going to be going. Where are we going? Here. You're going to be asked on your assessment, on your test, to find p of x minus 2 for the function. If you can do that, great. If you can't, it just means you need more practice. But the way I'm going to do this is going to be important because there is such a thing where organization becomes an issue. And what I'm going to do first is substitute. So if I want p of x minus 2, I'm going to do 4 times x minus 2 to the third minus 2 times x minus 2 squared plus 4 times x minus 2. And here's the thing. This is about a two-step process on its own. I don't want to do that two-step process within the range of where this 2 is at. That's a longer process, and I don't want to do that in the mix of all this stuff. So what I'm going to do, because again I'm older, way older, very, very much way older, I am going to set it up over here. So I'm going to do x minus 2 squared, which is x squared minus 2x plus 4, or x squared minus 4x plus 4. So that would be x minus 2 squared. Question is, what is x minus 2 to the third? Well, remember, that's just another x minus 2. So isn't that just this answer times x minus 2? And again, by doing all this over here, I can be as messy as I want because it's not messing up my organization over here. What happens to students when they get to this level of work is they do this work over here. They have it all mixed up with the 4, the negative 2, and the 4, and then by the time they get this answer, they forget what in the heck they were doing in the first place. So what I am doing is I am setting up my work. This is x minus 2 squared, and then I'm going to find the other one using the method I showed you. So x to the third minus 4x squared plus 4x, that is negative 2x squared, that is plus 8x, and that is minus 8. I believe negative 2x squared plus 8 minus 8, which gives me x to the third minus 6x squared plus 12x minus 8. I'm going to trust that's right. Now, this is my x minus 2 to the third. And now what I can do, because I don't mind doing work over here, I just don't want to do all this messed up work over here, is now I convert this to 4 parentheses, whatever that is, minus 2 parentheses, whatever this is, plus 4 times x minus 2. And I want you to pay attention to how much nicer this is going to be work-wise in terms of organization than having all this stuff mixed in with there. Because now we simply distribute a whole bunch of junk and then we put it all together. 4x to the third minus 24x squared plus 48x minus 32. Be careful because that's a negative 2, and I think I did that on purpose, and it's probably a negative in your homework too. Minus 2x squared plus 8x minus 8 plus 4x minus 8. And now we take our numbers and put it in standard form. 4x to the third, x squared there, x squared there, that's it. So that is minus 26x squared. X is there, x is there, and x is there. So 48 plus 8 is what? 56. Plus another 4 is 60. I was making sure I was looking at the right ones. I think it's smarter to go ahead and do that whenever I'm done with my x squareds and x's, so that way I know. So 48, 56, 60. And then I take the last ones and circle them. That makes negative 40. Ooh, that's it. Simple, I know. They're going to ask you to do the same thing with a negative x squared because they want to make sure you understand how to deal with signs. Typically the way you grow up in math is you learn how to deal with negatives, and what people like to do is forget that this negative is not really attached to that x. That is how that gets substituted. Minus 8 times x minus 9 minus 1. Why does this one only have a squared? Because I put a negative in there. There was no need to put a negative in front of all that because of all the work you had to do. But we still need to kind of go over here and do x minus 9 times x minus 9, which is x squared. Whenever you're multiplying these and you have an x and a number, by the way, just a regular x, not a 2x or a 3x, it's going to be this times that, and then this plus that, and then this times that. Showing you up here, x times x is x squared. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 2 is positive 4. Something you want to practice so you can get faster at it or better at it. Other than that, you get negative parentheses x squared minus 18x plus 81 minus 8 times x minus 9. I'll do all my distributing at once instead of confusing myself. Now I'm going to distribute a negative, which means everything switches. Now I'm going to distribute a negative 8. Remember again, this is a negative 8 because Mr. Bradley loves to put you in a situation where you'll make the silly mistake and have to ask for help, because that's really the only way you learn. And then minus 1. Then we put it in standard form. Negative x squared is gone. X, that is plus 10, gone. 81, 72, 1. This makes 82, or negative 82, and plus 72, which means minus 10. There you go. And that's the first portion, by the way. So 8 minutes into your video, congratulations. If I almost confused you, there is more. But again, I think you can handle it. Otherwise, I wouldn't have you doing it. Second portion of work requires discipline. So be sure to copy the definitions for future memorization. These concepts go all the way up to calculus and beyond, and there are words that you will hear. The degree is the highest power in an expression. The leading coefficient is the coefficient that is attached to the highest power. It's kind of like the first lady is the wife of the most powerful person in the world, or in our country at least. So again, leading coefficient is a number that's attached to the strongest variable in the whole problem. Odd versus even is determined by the degree of the function. Visually, I think of the dancer. I'll tell you that in just a second. Relative maxima occurs at the top of a hill. Relative minima occurs at the bottom of a valley. Let's go back to this dancer I was talking about, because again, I like to teach you in ways that will stick, and I want to tell you about a day in which I went to my dance to prom, and my favorite song came out or was playing, and so I walked to the middle of the dance floor. I told everybody to give me some room, and then I went out and I did the John Travolta, where one arm goes up, one arm goes down. This would be odd if someone went to a dance and simply went to the middle of the dance floor and pulled a John Travolta and stuck their arms one up and one down, because that is a whole different dance. I think that's in the 70s. And so to me, whenever I think odd, I think of someone with one arm up and one arm down, because that would be odd. So whenever you think about that, odd means one arm up, one arm down. Even means both arms up or both arms down. So that's kind of how I think about it as a dancer. So whenever I think about odd versus even, that's kind of what helps me to remember it. And again, I did these things to pass my classes, and I like to pass on my greatly developed knowledge to my students. The next step is based on our ability to translate our description of left and right. Left on a number line. Remember, this is X and this is Y. Left will be the phrase as X approaches infinity, because that is the furthest number to the... I'm sorry. I was reading it wrong. Left is as X approaches negative infinity, because the smallest number or the biggest number that way is infinity, and it's in the negative direction. So as X approaches negative infinity means left. Right is as X approaches infinity, because that would be to the right. Again, the key is remember that X goes horizontally and paying attention to the values and directions. After that, you must translate your definitions of up and down. Up is no longer Y, because we know that Y is the same as f of X, which means I probably just taught you all wrong here, but Y is f of X, because remember, f of X equals means Y equals. But other than that, up is f of X approaches infinity, because that would be positive numbers. Down would be f of X approaches negative infinity, because again, that is going down, and that's the biggest number going there. So in the end, we have to put everything together into one problem and analyze it using our newfound understanding. So let's look at a couple of examples and see how it works as we learn some things that go on about what's going on. Certain things you should know. Y-intercept. Y-intercept is typically that number there whenever you have everything is gone, so y-intercept would be negative 8. Is the function odd or even? If there's no picture, then you look at the highest degree. The degree is here. Actually, before we do that, there's another way to determine the odd or even part, and that is to draw. Actually, do we want to do that yet? I don't know, maybe not yet. Anyway, we look at the highest power, which is the 8. 8 is an even number. That means it's even. What is a degree? Well, the degree is the highest power. 8. What is the leading coefficient? Well, if that's the most powerful number, then the number attached is 7. Those numbers will be there. Complete the boxes to describe the left side and right side behavior. So here we go. This is where we have to learn some things. If your leading coefficient is positive, this is a general sketch. That means that it's going to go up in the end. So it comes from this direction. Everything else after that is up to you. So again, if it's positive, think about a line. If it's got a positive slope, it's going up. If it's negative slope, it's going down. So since it's a positive 7, because it's a positive leading coefficient, that means it's going to make everything go up. So it's coming from here. And here's what we are going to do. We are going to make 8 changes in direction, because that's what the degree tells us. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And what that does for me is I don't care about intercepts. I don't care where it's at. I just needed to make sure there were 8. Notice 1, 2, 3, 4, 5, 6, 7, 8 changes in direction. So what you're going to say is, as f of, you want to talk about the left side. So left side in behavior, left would be x approaching what numbers to the left would be negative infinity. F of x approaches what? So as x is to the left, so as you go to the left, what does this graph do? It's going up, which means f of x approaches infinity. Now you might have to actually type negative infinity and infinity, but that's pretty much part of what's going to happen. Right side behavior. As you go to the right, so as x approaches, again as x, which would be on your graph there, x would be this way, so as x approaches infinity, f of x approaches what here? So as x goes to the right, what is this graph going to do? It's going to go up, which means that it also approaches infinity. I think we just sketched a cheap graph. And the most relative maxima that it could have. So relative maxima is the top of a hill. That's 1, that's 2, that's 3. Because if you make 8 shifts, 3 is the most you can have. Now here's the thing. The 8 does not mean it goes 8 directions, but it means it can go up to 8 directions. So that at least tells me a maximum, which is 3. What is the most relative minima that it could have? Well, that's the low points. That's 1, 2, 3, and 4. And that is our analysis. Whew. Yes. Good thing is we're only 15 minutes in, so we're not 30 minutes in like it feels like. But again, the key thing to remember, leading coefficient positive means it's going to end in an up, and I draw it from here. So if the leading coefficient was negative, I would start from here and then start sketching, and that the number of adjustments I make is based off of that degree, which is 8 in that case. First things first, what's the y-intercept? Notice I don't answer these things in order. Y-intercept is, again, the number over here, which is -2. So if I'm looking at an SAT question or an ACT question, and the picture doesn't cross at -2, then it cannot be the answer. Cross the y-axis at -2, that is. It's like, I'm sorry, it's not up there, silly. It's down there. So if it doesn't do something and then cross right there, then I know it can't be it. Anyway, is the function odd or even? The degree is 7, so it is odd. That means it's going to have the arms going opposite directions, because going back to what we know about odd versus even, remember I said odd is the dancer, one arm up, one arm down. Notice both arms go up, so even is what it was. The degree is 7. The leading coefficient, again, is the number attached to the most powerful variable, which is -2. Here we go. Best thing to do is to answer some of these things. So what I'm going to do is get to the bottom, which is a cheap sketch. Remembering that it is a, I'll do this somewhere more visible. I guess I'll do it on the back of paper. So what I have here is, it's a negative leading coefficient, which means it's going to end off going down, which means my graph is going to start somewhere around here. And then I'm going to make 7 direction changes. Doesn't matter where it goes. 1, 2, 3, 4, 5, 6, 7. I just need to make sure I have 1, 2, 3, 4, 5, 6, 7 sections, and then I can answer these questions. So as x approaches, first off, you want left side behavior. It's telling you that on the part. Left side would be this one. So as x approaches, again, -infinity, f of x, which means up or down, the graph approaches, it's going up, so that would be infinity. So again, as you go left, as x approaches the left side, f of x goes up. Right side would be as x approaches infinity. So as x goes to the right, the graph goes down. Well, how do I show down? That would be -infinity, because remember, that's what f of x down is. There's your cheap representation. What is the most relative minima that it could have? Again, minima are at the low end, so 1, 2, 3. No, I'm sorry. I guess that is 3. Maxima is the other one. 1, 2, 3. And there we go. So that question is on your work. Again, it's going to take some work, but again, that's thinking more than anything else, just making sure you adjust to what's going on. So considering this image below, again, you're also going to have something to give you an image. Describe the left side behavior. So what you're going to say is, as x approaches, again, left side is x is -infinity, and again, you might need to type it, comma, f of x approaches what? So as you go to the left, my graph is going up, so that would be infinity. The right side in behavior on this graph is, as x approaches infinity, because remember, infinity is to the right for x, because again, x positive infinity, x negative infinity. So as x approaches infinity, f of x approaches what? As you go to the right, the graph is going down. How do I show down for f of x? That would be -infinity, because again, that would be your infinity, that would be your -infinity, and that is what you're looking at. How many relative maxima does the graph have? Let's see, 1, 2, 3. All it is analysis. How many relative minima does it have? Let's see. 1, 2, 3. State the number of real zeros. Oh, that's important. Real zeros. That is where it crosses. Remember, zeros, this is where all this stuff comes in together, is the same as solutions. Remember that stupid question I gave you and you think it's really stupid but you had to answer it and read it? Is the same as roots. Is the same as, can you remember the last one? It is x intercepts. So 1, 2, 3, 4, 5. Is the function odd or even? Well, look at the arms. One arm up, one arm down. Whenever it's arm up and arm down, that means it is a odd function. So that's pretty much what you're looking at there, all right? So again, expect to have to think, expect to have to talk to me, and if you don't, well, just either don't care or you know it all, which is not something I can handle either, or not something I can fix either way. The important thing to remember is that the skill must be used to be developed. You have to learn how to interpret connections between functions and their graphs. We are honestly not going to go too deep into the analysis, but again, the goal is to add higher level of connection a bit at a time. So please let me know if you have any questions. Email me. I guess the best way to do this would be to email me the question if it's an analysis thing and ask what it is specifically that you want to know. Like, how do I tell whether it's odd or even, or how do I tell whether this? But again, sending me a message that says I don't know how to do this is not going to work, because I will simply say go back to the video, because the video told you at least most of what you need to make a decision. But other than that, just make sure you answer the last question, and good luck.